G'day champions. I was just going through the old hard drive and I realised I never did a follow-up video on the 30th anniversary Vox AC30, so it's a beautiful day here. So it's been like this for about 10 or 12 hours now. So it's a great day to sit inside in the warm with the fire going and on the computer edit a few videos and have 1,000 coffees. Champions! We got this one approved. So I've just battled with the board and all the connections and hardwired crap and linked leads and stuff. We got the board out, so let's go snippity doodah and we'll remove everything that needs to go in the bin. So first things first, we'll remove this, what used to be a connector. Someone hard soldered everything, but instead of soldering to the actual solder pads, they've just soldered to the ends of the pins on the header. So, and then they've wrapped it, so there's no quick and easy way to remove it. What I'm going to do is just desolder this thing from the board and then address that later. I don't think I'll be putting a connector back on there because I've got a feeling this must have been a failure point at some time, probably because of the excess current expected of that connector, which every manufacturer loves doing. If you're going to design an amp using a Molex connector to carry heater current, spread the load across 3 or 4 pins, like per side. So, well, sorry, say 2 to 3 pins per side. So you 6 pins total or 4 pins total. Share the current across multiple pins. It's a known way of handling high current in a connector that's not rated for it. Just share it between the pins, but nobody does. So they put a 4-pin connector there or a 2-pin connector and expect all that current through 2 pins, and of course it burns. So we'll desolder this one and we'll just get the board where we can work on it on a nice flat surface instead of this half in, half out of the chassis bullshit. Try to be pretty quick on each joint because this foil on the circuit board's a little bit suspect. Alright, so those big traces, the solder's still holding on top, so I think I'll use a bit of braid on this one. I know Lyle will love me. Lyle loves braid. This one's really good, Chemtronics. It's got lots of flux in it, so it really soaks up that solder like you wouldn't believe. Alright, so I've desoldered all of them. Careful not to rip any pads off. And there she comes. So that can stay there. I'll decide what I'm going to do with it later. You can sit there and think about what you've done. And our board is free. So we'll get rid of the chassis for now. Get rid of my schematic with all its secrets. And we'll get nice and comfy with the board because we're in for the long haul. Oh, that's nice, isn't it? Is that some Hindu shit or something? Whoever worked on this last must have been from up the mountains. They love that shit up there. Alright, so here's our board in full HD. There's the sockets. We're going to replace some of them. Probably the EL84s at least. I'm tempted to replace all of them because there's a lot of dodginess. Whoever reflowed them last did some pretty poor work, as we're used to seeing on this channel. So often when you look at work done, you can sort of, it's like a little journey into the mind of the previous tech and what they thought they were doing. So this socket here, I've never seen that exact socket in anything except old radio equipment. So I've got a feeling that's a pull from something. It's got a little symbol there, a little cube, 9201. That's the difference. You can see it sits a bit higher. Not that it really matters in this area, but it does have a shield on top, but I don't think there's anything actually contacting the preamp valves. That's just like a retainer on the output valves, the EL84s. But you can see here, let me get my pointer, my little pointers, and you can see here there's a central sort of like a rivet thing on the other valve sockets. That's it there. And it's soldered. So they've butchered it and just cut it off, left a little bit floating around, and we'll clean all of this up. I'd like to replace that socket, I think. It's not real crash hot. We've obviously got our cathode resistor bastardry happening here, with stuff just floating around. It hasn't cracked the solder joints yet, but it's just not a great way of doing it, is it? We can put a 10 watt there. There's enough gap between the terminals. We've got the melted ass connector. You can see it's sitting on a funny angle as well. We've got the 100 ohm screen grids, which I'm going to be increasing to at least 1k to protect the screen grids. We've got, someone's recognised that the heater trace comes extremely close to the grid, control grid. So they've scraped back in that area. Vox has a few amps where that's the case. The traces pass ridiculously close to each other and they're very large potential difference. In this case, there's not a massive difference. So throughout, it looks like they've replaced, whoever's had this last has been a orange drop fanboy. There seems to be this persistent rumour that orange drops make everything good. I couldn't think of anything more idiotic. People make whole careers on just shoehorning orange drops into inappropriate places, and that's what's happened here. So look at that lead under there, bent hard at 90 degrees, coming over. They've got a bit of heat shrink on there at least, but thick leads, often they rip the through-hole plating out if you need to replace them, or they do it in the process of replacing them. And that's throughout. You can see everywhere where there's an orange drop, because they're ridiculously large, they've had to bastardize the leads. It's there and it's up on this one. I just don't get it. What? Every one of them. So they've probably damaged. They've probably, of past experience, they've probably destroyed the traces down there as well. And you got this huge cap floating on about a 6mm lead spacing, which is just stupid. Get Panasonics. Honestly, what is it about being orange that makes you think these things are amazing? They've done the same with silver micas. There's also mythology with silver micas that they're somehow better than a good quality ceramic. It's all just uninformed bullshit. There are some places where they may be more suitable, but a good quality ceramic is always going to kick a silver mica's ass, particularly when these things get leaky and they start becoming noisy and microphonic. You're not too fond of them then, are you? You got to pay to get them replaced. We've got the shoehorned in Vive Tram Volume Alpha 1 Meg audio taper PCB 24mm thingy, and granted, these are a bit of a pain in the ass because they're what, 20mm, so they're different to the 16s that are common, and the lead spacing is too large. You might be able to fit some 16s in there if I've got some with slightly longer leads. The other one I've done quite often is you get the Burns ones, which have eyelets, but they're on really long fingers, the eyelets on the end of the finger. So you just cut the eyelet off and you've got a really long lead there, and you can mount it to the circuit board. It's getting bolted to the chassis anyway, so it doesn't have to be like a, like one of the modern amps where it's got to have these reinforcement plates or anything. It's just bolted to the chassis. You just got to be careful not to stress the joints when you tighten up that nut. So another thing I get quite a lot is people assume that a cap's on the way out when they see this bulging dome on the top there. Well, that does say that it's been exposed to a bit of heat because the plastic wrap's shrunk a bit. You push those tops down and you can feel that the aluminium on top is flat. So that's not a catastrophically failing cap. We're changing this one anyway because we're doing a full recap because the amp's 30 something years old and it's a main gigging amp. But that there you see on Marshalls, you see on Voxes. It's not the end of the world. So if I cut that off, hey, there it goes. See, the top's flat. No bulge. Doesn't even vent from there. You can see there's no little cuts, little scoring in it to create a surface that will bulge open in a controlled way like there is on most caps. This would have the vent in the bottom plug. You can see evidence here. That's the first filter cap, the reservoir cap, I mean. It's starting to bulge there. So that is a vent behind that. And that is starting to fail. So we're definitely going to change them out. That got approved in the quote. Some of the other ones you can see a little bit of crusty stuff starting to leak around the lead. So that's showing there starting to fail too. Might be a bit hard to make out in this video, but with the proper light you can see down inside here there's little crusty starting to exit around the lead. It almost looks like, I don't know, like sand coming out, because the electrolyte dries as it comes out and leaves behind the solid residues in it that were previously dissolved in it. So long story short, we're doing a full recap. All the electrolytics replaced. I'll change this one out too. That's the bypass cap for the output stage. There's not a lot of caps, you know. Like, what do we got? 1, 2, 3, 4, 5, 6, 7, 8. 8 caps, 9 caps, 10 caps, 11, 12 caps. So, why not replace them while we've got it out? Makes sense. There's not many, and we'll put in some long life 105 degrees because it's a Vox and they do run warm because they're in an enclosed box. So the higher rating and longer lifetime models you can get, the better. Okay, so there is a little bit of horror happening under these sockets too, so we're definitely going to remove them to even just have a closer look. You can see they're sitting on an angle. That's not great. And the pins, they've just gotten super hot. You can see it's made the solder go crusty. So that means the solder was on the verge of melting itself. It's got so hot that it started to actually oxidize. And that ain't no good. And this socket on the right was so loose, had an EL84 in it. It just sort of pops in. There's like almost no resistance. So you can sit there cleaning and retensioning till the cows come home, but I think for this one we'll just chuck some new Beltons in there and be done with it. So now we get to my favourite bit. Snippity-doo-dah, snipping out all the detritus. Now snipping it isn't just because it's satisfying. It also means that we don't have to heat the joint for as long to remove the lead. It means there's less mechanical strain on the joint, like when you're heating it up and trying to pull a lead out. It can get pretty stressful on the joint. So all we have to do is get the tweezers, melt the solder, pull the little remainder of the lead out and suck up the solder. Get rid of the screen grid resistors, I should say. Check the stoppers for resistance. It looks a bit suspicious. 2 are down on the deck and 2 are up in the air. And you can see there's some dry soldering in that area as well. There's just blobs on stuff with no movement, but yeah, not looking great. So I think we'll give this whole area a wash with solvent, see how bad any damage is, remove the solder, see how bad the damage is under the solder. And then if we need to do any reinforcement with turrets or something, we'll think about it then. But let's not count our chickens before they something. Well, I'm really tempted to get rid of all those orange drops and put in sensibly sized caps that won't wobble and damage the PCB. I don't want to damage the pads on the PCB any further by heating those joints, because it looks like he's actually ripped a few pads in the process of putting all these caps, shoehorning the caps in there. And things are happy now, but if we go ripping them out, we might have more to deal with. And you know, they're working. I'll check the values. There's a few values I'm going to change. just to bring it a bit closer to the JMI spec. But yeah, look, I don't really want to go pulling out those big fat leads that have been bent over and a lot of heat added to the joint. You want to be in and out as quick as we can on each joint. There we go. Well, there's no bulging. It's got the distinct smell of electrolyte, and techs know what I'm talking about. It's like a piss combined with just a musty old smell. And it's you once you've smelled it, you know it. I've smelled it a lot. I'm sure there's different formulations, but they've all got a similar stank to them. And anyone who's done a large recap on surface mount equipment will know what it smells like, because you use the heated tweezers to pick up either side of the electrolytic caps and remove them as quickly as possible. And sometimes the little caps can't handle the heat and they actually explode, and they're tiny little things the size of a grain of rice, you know, or a baked bean or something. But they stink when they let out the smoke out their base from the heated tweezers bursting the container. Anyway, that's boring as shit. So next subject, let's change the valve sockets. Might add some more solder there first, just to get the flux out of it, or into it I should say, onto it. I'll get Mr. Boffer going again. I'll set it down low so it doesn't deafen you. Alright, so I just cleaned up the first one, and it's looking promising. I don't think the pads are going to break because they're through-hole plated, so I think we should be right. If anything goes awry, I'll just have to run some wires. But this side turned up pretty well, so I think we're going to be okay. I'll just remove this super shitty looking connector. Ugh. Oh, what the fuck is that? The flux. It's like it's like I'm burning chocolate or something. I don't know what. I've never smelled flux like that in my life. Bargain basement solder. It turns to coal as soon as you put heat on it, so oh, that's a lovely job, isn't it? In the bin. So that connector was the plate connections to either side, and it looks like someone's had a problem with conductivity or maybe arcing in that area before, because they've dug the living shit out of it. They've Douglased it. So I might cut this off here and here, because that doesn't look great still to me. It's blackened and it's pretty mank. It doesn't look like it's got conformal coat on it either, so the fiberglass in that area might have absorbed some moisture, which isn't good. So I might cut this trace back here and here. We'll hard solder stuff just directly to the trace, or maybe to the nearest pad, and that will be the plate connection. Ah, bugger it, let's do the bloody grid stoppers too, eh? It'll look silly if we don't do the nuclear option. We'll just rebuild the whole area. Why not? Nothing better to do. that valve pin snapped off as I was desoldering it. Look at that. They are super shitty sockets, so I reckon we change all of them. Yeah, we'll change all of them. Look at them. The leads are like foil. Really thin and really narrow too. I just noticed that one that I removed previously, two of them had already snapped off. So, it could have been that was the cause of the intermittent signal. You compare them with the belt and there's no comparison, mate. Look at this hunky bastard. Look at this pissy little pissy thing, pissy. It's no contest. So, just check that the pins line up. And they certainly do. So we'll just check the height, because they are standing a little bit taller than the stockies. Oh, wrong side of the board. You know what I mean, mate. But yeah, they're probably another, I don't know, 1/8 of an inch taller. So we'll just check that's not going to clash with anything before we go soldering them in. But yeah, they'll work, and they're very nice. You know, the worst part is the legs are snapping off, they're getting stuck in my desolder gun, so I'm going to have to do this differently. I'll just heat the joint and remove the pins. Yeah, that's good, isn't it? Only 2 pins held on that one. Right, champions, well, we've cleaned up the area, we've removed everything in the power section, or the output section I should say, and it's come up alright. And I've noticed that bubbling is actually just under the solder mask, so the foil is still stuck well to the board. If I get a bit of braid there, looks like it's a bit bubbly. Put a bit of braid on there. It's just taking the solder mask off. The foil underneath is fine. So that's a relief, because that means that all our solder connections will have a better chance of standing up, or lying down as it were. And on this side, I'll just put a bit of alcohol on there to soak it up, but a little bit messier, but everything's intact, and I think it's a goer. So we'll I'll check the sockets have clearance, and looking at how flimsy those sockets are and how easily they broke, I think we're just going to go ahead and change every valve socket on this amp. Otherwise it'll be back. I'll be back. So 1, 2, 3, 4. We've already done 1, 2, 3, 4. So that's 8, 9, 10. 10 valve sockets in total. It's a bit of work. That's what old Voxes take, mate. So for now, I'm going to be done for the day. I'll see you in about 3 seconds in video land, but in about 2 days in real world. Yeah, so we're going to change all the sockets. The one that was replaced, again, what would a Brad's Guitar Garage video be without showing some previous butcher's bullshit? Instead of actually getting a PCB pin socket, they got an eyelet socket and cut half the eyelet off, and that made each one a little hook, so it's hard to remove without damaging the through-plated holes. And it was very weak because it's got a tiny little cross section to it, so pretty prone to snapping. So that one goes in the bin. These wires, I don't know why they used them. That's the phase inverter outputs. There was no break in the trace, so I don't know why they decided to reinforce that. But again, you go crazy trying to figure out how the previous guy thought, because they didn't think. I'm getting rid of the stupid massive caps because they're not JMI spec anyway. We're going to change some values partially to help reduce that trem thump or vibrato thump, whatever you want to call it, and just to clean up the overall response of the amp, make it sound like an AC30 should. So we're changing the values, so that gives us a good excuse to fuck off these stupid massive things. In the bin. I'll give all the parts back to the customers, but get rid of those two as well. They're the output of the phase inverter couplers going to the output stage, so we'll remove them, change the value, bring the bottom end response a bit tighter. So just on them, the massive leads going through, they've twisted them over and folded them over to try and make connection to the socket, and you can see the socket sitting on an angle. Probably got broken pins as well. It was giving output as you saw in the first video, but a little, like, you barely move these things and the legs break, so that was probably the source of some of the intermittency. Anyway, we're gonna redo them all, clean everything up and make it schmicko. Oh, now I've removed the comically large capacitors. It became evident why he's run extra little wires on top of those traces, because those huge leads, well, when he removed the previous capacitors, whatever they were, probably didn't remove the solder or had a little kink on the end of the lead still, so it just ripped the pads out when he's removed them. So just run another wire to compensate for that. You can see the damage to the pad there. It's almost non-existent now. So yeah, once again we'll be reconstructing little bits of the circuit using wire to compensate for the incompetently damaged PCB. It's part of the course, really. So, well, these aren't the easiest sockets to remove. It's not impossible to do it carefully and not damage the circuit board in the process. As the previous guy, I wish he knew that. A bit close to that cap there. Have to be careful not to melt it. Putting some fresh solder on there primarily to get the flux out of it. Once we've removed all the solder from the pins, sit your soldering iron in the center of that brass tube until the solder starts to melt, and gently work it until the socket pops out. There she is. The old the socket that was already replaced, they just mangled it and cut it with pliers and stuff, but that's the easiest way to get rid of it. Alright, so we've depopulated everything, all the crap that I want gone anyway. We cleaned the board, got rid of all the flux residue, gave it a good soak with IPA, not India Pale Ale, isopropyl alcohol, although it's almost beer o'clock, 2.5 hours away. Yeah, so we just cleaned everything up, checked that all the traces were okay. There's somewhere we might have to rebuild them a little bit with some bus wire, but it generally looked a lot better than I expected. So we can begin the slightly more fun process of repopulating the board and go from there. Alright, champions, we've repopulated the board. We've got new bypass caps. We've got a new bypass cap for the output quad. We've got new screen grid resistors. We've got new grid stoppers. We've got new filter capacitors all around. We've got rid of those oversized orange drops here, and we've changed values. We've got a JMI spec value film cap in here instead of the massive orange drop there as well. I think I'll leave these ones in. We'll have a listen and maybe tweak some values from there, but we've got all new sockets installed. The board is flux cleaned and we're ready to possibly start wiring it up. A few other little mods to do, like the I don't like the way this pot's mounted. I've got to think about whether I want to keep this jack board or mount some eyelet jacks and run the wires to that. Yeah, that one's got to go. I don't like the way that's mounted. And change the, which one was it? The Vibe Trem Speed one to a 3 meg reverse audio for a bit more of a even distribution across its travel. And I've put a 75 ohm for the cathode resistor there, and we'll see where the valves sit with that, and if we've got to change it after that, we'll do it, but that'll cool things down a bit, but not so much that the B plus goes through the roof. We've got 450 volts all the way through, so even with no valves in and switched on, if someone ever does that, then the caps will still have a margin for error for the voltage rating there. Instead of having in its stock form, it had two 450s there, one for the res, one for the screen grid node, and then the rest were 350 volt. If there's no load on it, that could be exceeded, that 350 volts. That's at first switch on, but yeah, it's not really a use case scenario. I've got one cap on the way. That's the filter for the DC heaters, and that's about it. We'll soon be ready to fire it up and have a listen and see where to go from there. Rightio, champions, we finally got this thing back together. Jobs like this, man, they look simple, and in the customer's mind, it's like, well, it was working before, it must just need a little, you know, a little tune up, a little tweak, like just brush the dust off it and Bob's your uncle. But the amount of work, like even this panel, like for example, the screws were just the wrong type for the job. They were there from the factory, but they're stripped. So do I drill that out and put threaded inserts in and put machine screws in? All of this stuff adds up. Fasteners, the wrong type, stripped. The stupid connector, which I bypassed and rewired, and in the process I cleaned up the wiring and ran new looms because there was splice galore from the last guy. So I had to, instead of putting another friggin' splice in there so it can reach the board, I just cut it off where it started and just ran a new loom. Just, this all adds up. We replaced the first pot, which was dodgily installed alpha job with, it's a PC pot, just generally pretty crappy way of doing it. So I just chucked in a new Burns one there. I like the Burns taper a bit more anyway. That's really suited to amps. It's not really suited to guitars. The Burns taper is a bit crap on guitars because on a guitar you're generally maxed out and you pull it down from there and it's a bit abrupt. But the gradual up from 0 is very smooth, so it's really good in an amp. And then when you crank it all the way, it goes all the way, right? It's got a real big peak at the end. They're still all the same taper, but from brand to brand, they vary. It's a proprietary thing. Anyway, we changed the normal and brilliant volume controls to be 500k as per the original JMI. We did a bunch of JMI revisions. Revert. I don't know, it's kind of a word. It is now. We did a modification which I'm very happy with. I just had a quick listen to just the signal generator, and we adjusted the speed range. So the original pot was a 2 meg linear. We put in a 3 meg reverse audio, so the same type that you find in like a Fender vibrato tremolo circuit. We changed the value of its end stop resistor to bring the range into a really nice, really musical range. Rewired the switch down here, which was a replacement from someone, but it had ridiculously thin wire and it just broke. So we redid that. Everything that we pulled out and redid, we had to put new wire on because it snaps, and the old wire was crappy solid core, so we put in some new stranded stuff. Just, if I charged the amount of time it took on this thing, it would have been a $3,000 repair plus parts. Like, but I'm here, I'm doing it, customers coming and going, selling stuff and whatever. So, you know, it's a good thing I love it, eh? But anyway, we changed a few parts. I went a bit fancy in the output stage here, the phase inverter. I thought, let's try a couple of carbon comps where it matters, where there's big voltage swings. And really, I haven't drunk the Kool-Aid on it being a massive thing, because I'm generally a bit of a, I don't know, contrarian when it comes to vintagey bullshit. But if it's going to make a difference anywhere, and some of my really well-respected colleagues, respected by me, not by forum idiots, they recommend it, and they do it, and they install it, and they swear by it. So I thought this is a good opportunity to try it out and just see if there's any magic in it, right? So ideally I would have done everything except that and then changed it out and tried it out, but this is a job. I've got to try and make money on it. I've got to try and get it out the door. The guys ring me every day. So I'm not going to do a massive A-B comparison for the benefit of YouTube. I'm going to continue to earn an income instead. So we ran over all the stuff we did last time. It's still running a bit hot. I've got a 75 ohm cathode resistor there, shared between, you know, all four as a standard setup. We changed the screen grid resistors. We changed the grid stoppers, and yeah, she's running around 118% at the moment, which is still a bit warm. But the problem is that the plate to cathode voltage at the moment is about 362 volts. So that's a bit high, about 360 volts. So we'll play with that value. I might bring that up to an 82 and see where that sits. But if we take too much load off the thing, it'll swing the voltage the other way, and and we might end up fighting ourselves, chasing our tail. I really want these valves to last a long time though, because of the current global situation. I really want all the amps I put out of here to get some good life out of the valves. I don't want them coming back in 12 months with burned up valves, because it's a Vox and that's how they sound the best, allegedly. Because we'll just burn through the current supply and we won't have any left, basically. That's the sad state of affairs, but anyway, I'll deal with that when I've got a schooner tonight. So let's fire it up, we'll have a quick listen, and I'll show you the change to the vibrato trem circuits, and I might change that resistor out, and we'll go from there. Now I'm plugged into the Vibe trem channel. While the normal was still up from testing it a minute ago, I noticed a pretty obnoxious hum. But then I also noticed it goes away when you hold down that shorting contact, so the jack needs replacing. But that's easy, that board's a swing out one. We'll take care of that. But you turn the normal down, we're on the Vibe trem channel. Pull out we'll play it with the trem off for a minute. Vibe trem. Sounds a little boxy. So it's the lowest of the range. That's about halfway. And that's all the way up. Change to a Vibe. That's with the cut all the way down, by the way. Yeah, it just sounds really mid-heavy. Going to the normal now. All that bass is back. That's with all the tone at 12 o'clock. So the treble and bass maxed out and cut all the way down. All little meters are going nuts. They're just, yeah, measuring the output transformer drop. So we'll turn the cut up to halfway. Then all the way. into the Brilliant. So there's thump there. Hear that? But only when nothing's plugged into the normal. So that's the normal maxed out, guitar volume down, no thump. So I think it's that jack, it's just picking up crud. So if we hold that down, it goes away and it's like dead silent. Tiny bit of hiss all the way up, but damn near dead silent. So fixing that jack will fix that thump. So in the meantime, we'll turn down the volume control just to ignore it. We'll go into the brilliant mate. Just like Billy Connolly. It's fucking brilliant. Oh, there we go. There's that take your head off brightness. I had the tone all the way up, the treble and bass all the way up though. So that's with them at 12 o'clock, and again it's a bit boxy. Treble control needs a bit of a clean up, but the treble really interacts with the mid-range. So you bring it down, that's treble all the way down. We'll go halfway up, just listen to it change. Down, all the way up. So it actually, the treble also cuts the mid-range as you turn it up. The treble does, it seems more dramatic. And almost you can hear the peak shift almost like a phaser pedal. Listen to this. So you can hear the resonant peak moving around, as you could probably show with the modeling software, whatever it's called, tone stack modeling thing. We've got some oscillation happening there. As you turn the Brilliant up, that's with the treble all the way up. I'm not sure that's a real use case scenario, because that with the cut all the way down would take your head off. It could just be the speaker cable arrangement and having the meters attached, so we might remove them and see if that helps. Alright, so we've changed, just subbed in a 100 ohmer there, and it's sitting at about 97%. That has made the plate voltage go up to 382, 383 with respect to ground, but about 368 with respect to the cathode, which is what the valve cares about. So where we've calculated the bias is about 97% between the two valves on average on one side and about 100 on the other. So I think 100 ohms is the way to go, and hopefully the JJ's actually electro harmonics, sorry, hold it up to the plate voltage. But in the meantime, we've changed out this jack here, so now you can crank up the normal. There's no thumping. So we're getting there. I'll put that resistor in permanently. I'll disconnect these leads that we're using to measure the bias, and we'll just see if we've still got that oscillation we were having before with the guitar plugged in. Alrighty, so we put the resistor in permanently. We've dropped it down to the board level, well not board level, sitting above it by about half an inch for ventilation. And we've removed the measurement devices, the flukes, so there's not, you know, anode bloody coils going everywhere, you know, from the leads. We'll try it just naked and we'll see if we get that oscillation still with the guitar plugged in. Going into the Brilliant. Bit of the drones. Into the Brilliant channel now. Max it out. Everything 12 o'clock. thanks for watching, champions. I'll try not to forget to edit the final videos on an amp series from now on. Thanks for your patience on this one. Take it squeezy. And until next time,